Okay, so right now we're going to talk about how to add and subtract fractions. So this is actually a 7th grade TEK, but we are covering in our pre-AP accelerated math. And just to recap really quick, I want to review how to multiply and divide fractions and show how easy those ones are. So if I want to multiply two fractions together, say 2/3 times 1/4, all I have to do is simply multiply straight across. 2 times 1 and 3 times 4. And my last step would be to simplify. Right, so both 2 and 12 are even, so if I divide by 2, both my numerator and my denominator, I will get my simplified fraction, which ends up being 1/6. Right? Okay, and likewise, so to divide two fractions, actually I'm going to pull out a couple different numbers here. To divide two fractions, what I have to do is, at least the easiest way to do it, is to keep change flip, right? Instead of dividing by the fraction, let's instead multiply by the reciprocal of that fraction, right? So instead of doing 2/5 divided by 1/8, I change it to 2/5 times 8 over 1, right? So again, you keep the first fraction the same, you change the division into multiplication, and you flip or turn your second fraction, your dividend, into its reciprocal. And then you can do it as normal, as multiplications. Multiply straight across and simplify if needed. So this would be 2 times 8, 16 over 5 times 1, 5, which if I wanted to create a mixed number, that'd be 5 goes into 16 3 times with 1 left over. Right? Okay, that's our review for multiplying and dividing fractions. Now we're going to take a look at adding and subtracting fractions. So this is actually a little bit trickier. Here's a fraction, all right? I'm going to draw a fraction. This is going to be, let's do, well, actually, it can be pretty simple. Let's do a simple fraction, first of all, 1/3 plus 1/3, okay? So this is going to be pretty simple. If I take 1/3, it looks something like this, and I add another 1/3 to it. All right, there's 1/3. I add another 1/3 to it. I'm going to end up with 2/3, right? That's pretty simple. So if by chance your two fractions already have the same denominator, it's really easy to add two fractions together, right? 1/3 plus another 1/3 is 2/3. You just add the numerators and keep the denominator the same. What if your fractions don't have the same denominator? What if they are like, let's say, 2/5 plus 1/4? What can you do then? That would look something like this. And again, if you're drawing a model, I've seen this error a couple of times. If you're drawing a model of fractions, you want your whole thing to be the same size, right? You can think of it as a candy bar. I'm splitting up. You want the candy bar to remain the same size. So this one will be 2/5. So I'm going to divide it into 5 pieces. 1, 2, 3, 4, 5. Right? And then someone divide into fourths. Now here's what I got to do. I have to add 2 of these pieces with 1 of these pieces. And here's the problem. It's very difficult to add these up because if I add it up, I'm going to get something that it's not going to come out to be, they don't line up. Okay. In other words, I can't just take this piece and put it here because there's an overlap. Right? If I put this piece, let's say I add this fourth with that. Well, it's going to overlap a little bit, right? So what are you going to do? It's kind of tricky, right? So here's what we got to do. When you're adding two fractions, really the only way of doing this is by making them have a common denominator. So here's how I do it. Let's take a look at this exact same problem again. I'm going to change it a little bit though. Create a common denominator, right? Because we've already seen if they have the same denominator, it's really easy, right? So here's what I'm going to do. I'm going to create a common denominator. I think of how I want to draw this. I'm going to draw it like this. Okay, I'm going to draw my 2/5 up here. I'm going to make it a square piece of chocolate, a little bit more square. And I'm going to add that to this piece of chocolate. Okay, so this one is 2/5. Okay, so 1. Okay, we're going to add 2/5. So that'd be out of this square piece of chocolate. That'd be 2 of them, right? we're going to add that with 1/4. So it looks like this. Right? Okay. And I just set it to make sure your units are the same. Mine don't look exactly the same. But let's pretend that this square is the same as this square, the same size. If that's true, then these pieces are not the same size. Even though my drawing doesn't look like it. The pieces are different sizes, right? Because my totals are the same size. I'm dividing them into a different number of pieces. So these ones are smaller than this one. Okay. All right, so if I want to add these together, here's what I got to do. I got to make sure all the pieces are the same size. So here's how I'm going to do it. Right, I already have 5 rows here. I have 4 rows here. So if I do the opposite, okay, I'm going to take this one that has 5 rows. I'm going to make it into 4 columns. Right? And now, this candy bar has now been divided up into 20 pieces. And this candy bar, remember, they're the same size. It only has 4 rows. I'm going to divide it up into 5 columns. 1. And I'm really bad at drawing evenly, but there it is. Okay? So now, if you think about this, this is really the same thing. Right? This candy bar and this candy bar are exactly the same. They're exactly the same. I might create a new video about this later on with a piece of paper or something. But they're exactly the same. They're both the same size to start off with, and they're both divided into 20 equal pieces. And now I can very easily add these up. Because here I have 1, 2, 3, 4, 5, 6, 7, 8 20ths. And here I have 1, 2, 3, 4, 5 20ths. And if I add them up, I just take these ones and drop them down here, or I can take these 5 and drop them up here. Let's try that. Take these 5 over here and put them in here. 1, 2, 3, 4, 5. And I end up with 8 plus 5, 13 20ths. That's how we do it. Pretty simple. Not too bad anyway. Yeah, let's try one more like that. So I'm going to add, let's add 1/3 plus 3/4. Okay, 1/3 plus 3/4. So again, I have a candy bar, and it's a square one. I'm trying to make this the same size this time, because it should be the same size, right? Exactly the same. This one, however, is divided up into 3 pieces, and this one's divided up into 4 pieces. Okay, so you can kind of tell these pieces are smaller than that one, because you're sharing more people. Now I'm going to add one of these thirds with 3 of these fourths. Okay, so again, the way I can make them all the same is if I take this one that's already divided into 3 and I divide it into 4 this way. And I take this one's already divided by 4 this way. I'm going to divide it into 3 this way. Okay, now they're exactly the same. If I just took this piece of candy bar and I tilted it 90 degrees, whoop, it would look exactly the same. And now I can see that this is actually, it's not just 1/3, it's actually 4/12. Okay? And this one is 1, 2, 3, 9/12. And if I add them together, I could take, let's see, I could take these 4 and drop them down here, right? Take this one, drop them down here. Take this one, drop it down here. Take this one, drop it down here. Oh, I ran out of that one. I have this one left over, right? So my answer is going to be 4 plus 9. There's 13 squares. 1, 2, 3, 4, 12, 13, right? 13 fourths. I'm sorry, 13 12ths, right? How many total are there? There's 12 pieces, right? Which is the same as 1 whole and 1/12, right? 1 and 1/12. Okay, cool. Adding fractions, not too bad, right? So what if I want to do this without drawing the picture? Well, look what we did. 5/8 plus 2/3. Okay, this is what I'm doing, right? What I'm really doing here when I did this last picture was I multiplied the 8 and the 3, right? I took the 8ths and I divided them into 3 pieces. So I took the 8 and made it into 24 pieces. I took the one that was already divided by 3 and I divided those into 8 columns, right? So I ended up multiplying my denominators together. Actually, I want to write that in black just to be consistent here with how I'm doing things. Right? And then when I took these 8ths, these 5/8, right? I took 5/8 and I divided them all into 3 pieces. What that did was it tripled the number I had, right? I used to have 5/8. I divided them all into 3 pieces. Now I have 3 times 5. Right? So now I had 15. So really what I did was I took this number and I multiplied it by that number. Right? I did 5 times 3. Right? And likewise, when I took these 2/3 and I cut all them into 8 pieces, I octupled, right? I took the 2 pieces I had and I'm going to multiply by 8. So they get multiplied. There's kind of a cross multiplication going on here, if you want to think of that way. So again, if I draw this, I'm going to draw the 2/3 one just for fun, okay? I'm not going to draw both of them on this one, but you can get the idea because I just did it twice, right? Here's 2/3, right? And again, what I'm going to do is convert it into, to add the fractions, I'm going to take this and divide it into 8 pieces. So what I'm really doing here, this is going to be really messy because I don't, my marker is, okay, you can tell, I just multiply by total number of pieces. It used to be 3, now it's 8 times 3, 24. And the ones that were red, it used to be 2 of them, but now it's 2 times 8, which is 16. Right? So if I did that with both of them now, I would have 5 times 3, I would have 15 in my first candy bar, 15 24ths. Right? In my second candy bar, I would have 2 times 8, 16 24ths. And if I add those together, I will get 15 plus 16, which is 31 24ths, which I could say is 1, and 31 minus 24 is 7 24ths. Right? Okay, let's talk about another way of doing this now. This will always work. So here's one way of remembering this thing, actually, before I get into the other way, is I remember it with a mnemonic add. Okay, to add fractions, what you got to do is you got to multiply the denominators across. Okay, so again, I multiplied 8 times 3 straight across. Then you multiply diagonally. Your first diagonal goes from the 3 to the 5, and you get 15. And then you multiply it diagonally again. 8 times 2, 16. Okay. See how that goes? And remember, just for consistency, I'm multiplying from the bottom to the top, right? So 3 times 5 is 15, 8 times 2 is 16. And that's that gives you, and then you add them together, right? Because you're adding the fractions, you can add whatever those are together. And that'll give you your answer. Now,